In our next question, well, the question wants us to have 2 points again. We've got the same 2 points, minus 1, 0 and 5, 2. What we want to do now is show the equation of the locus of the point px. So again, we're finding if px is going to move around, what's the equation of the locus? But the rule this time is that PA is perpendicular to PB. So you've got a point there at P, and then you've got A, and you've got B. And as long as that gives us a perpendicular, then the rule's going to hold. So if we know two lines are going to be perpendicular, we're going to apply our ideas that we know about gradients that are perpendicular. We're going to get the gradient of PA, and there's the gradient of PB, using P as xy, A is minus 1, 0, 5, 2. Now, we should end up with this equation, and we should see that this is a center and radius of a circle, but we'll do that in a moment. So we've got our two gradients multiplying to give us minus 1, and there's our expressions there. Can't do much else except multiply them out. So the y times y minus 2, x plus 1 times x minus 5 gives us the expansion, so we've expanded it there, and then I've multiplied through by the x squared minus 4x plus 5. And that's why every term is got a different sign from what it was in the numerator. Collect it across all one side, and we end up with this expression, which is what we wanted to do there. So there's our equation. It doesn't make much sense at this point in time. What we need to do is manipulate it a bit. Now, I do know that seeing I see x squared and y squared there, I do know that this is a circle. Okay, but what I need to do is manipulate it so I can get the equation of the circle. We want the center and the radius of the circle. I'm going to rely on the technique of completing the square. Now, we haven't used that very much, but this is particularly where you need to use it. So if I'm going to get x squared minus 4x, what I need to do is add 4, because completing the square, I'd take the minus 4, divide it by 2, and square it, gives me 4. And then completing the square on y squared minus 2y, I'm going to add 1, because that's going to give it a perfect square. You can see my perfect squares appearing there. Make sure we add the 4 and the 1 on the right hand side as well, because if we don't, then we're not going to get the correct value. So you can see our perfect square, x minus 2 all squared comes from that expression, and y minus 1 all squared comes from that expression. We had to add 4, we had to add 1 to get us our perfect squares there. Allows us to get 10, which means now from our equation of our circle, x minus h all squared plus y minus k all squared is equal to the radius squared. Our center, which is hk, is going to be 2, 1, and our radius is going to be square root of 10. So that one gives us the expansion. If we multiply it out, the two gradients equal to 1 minus 1, going through, getting our expression. But then to do this part, we need to rely on completing the square. If we don't complete the square, it's not going to work. In this question here, we've got the 2 points again, and we want to move so that P is equidistant from B and the x-axis. So in this case, what we want to do is look at our equation, and we'll look at our point. So if we draw it up, it's not a very good diagram there, but B is going to be some point, and sorry, B is 5 minus as 5, 2. And our point this time, P, moves such that it would be equidistant from 5, 2 and the y and the x-axis. So if that's the case here, basically that point's going to be equidistant, but so would a point that's there. And so would a point that's there. So we should be going straight down. So our point, this should end up being a parabola. Let's have a look and see if that works out. So if that's the case, what I want to do is get a point on the x-axis, and that to be L, which is x0. So if I draw it up here, we've got 5, 2. We've got P, which is some point xy, and we're going to get a point down here, L, because it's going to be most direct distance, so that's why it's going to be perpendicular there, and L is going to be x0 because it's in line with the x, but also it's going to be 0 because it's going to go on the x-axis. So if that's the case, PB is equal to PL. So we know P is XY, we know what B is 5,2. So the distance from P to B has got to be the same distance from P to L. And I've got L being x0, so I apply all those values in the distance formula. I apply the distance formula to PB and PL. Gives me, again, I've got the square roots on both. They can both cancel because it's the same, so I can square both sides. The x minus x all squared is going to give me 0 there. That's just going to leave us with y squared on this side. I'm going to have the x squared, x minus 5 all squared, y minus 2 all squared, expanded out, and notice the y squareds are going to cancel. Leaves me with 4y, when I clean it up, 4y equals x squared minus 10x plus 29, which is an equation of a parabola. So you can see the parabola there. If I want to put it as y is equal to a quarter of x squared and minus 10 for 4x plus 29 on 4, I can do that. Later on we're going to manipulate that so we can get things such as the vertex and the focus of this parabola. But that's going to come later on. All we need to do at this moment is get an equation, which is the equation of the parabola there.